In this segment, I want to begin chapter 13. We're going to just dive in. Now, density is a term that you probably have seen before. You've almost certainly encountered density in some other class. So we're just going to hit it really quick. In this case, we're talking specifically about mass density. And so mass density is defined as mass divided by volume. How much mass in how much space. Mass, recall, is how much stuff, right? And volume is how big or how much space an object occupies. And so, I have a couple of objects here that I got from my backyard and my garage, respectively. And I have here a rock. Ooh, and I have a piece of insulation. Now, these objects are, pretty close to the same size. They're slightly different shapes, but, they're very similar in size. And I want you to guess which is heavier, the rock or the insulation. Yeah, it's not that hard. It's the rock, right? It's the rock. Oof. But they're about the same size. How can two objects of the same size have different masses? Well, they must have different densities as well. So which one has a greater density? Well, definitely the rock has a bigger density. The insulation has a smaller density. Why? Because this has less mass than this does in approximately the same volume, right? Same volume, greater mass, greater density. What if I took a little tiny piece of this rock? What if I broke off a chunk of it? Well, I don't know. Let's see. Don't tell my wife. Oh, here we go. I got a chunk. It's very tiny. It's a very tiny piece of rock. How does the mass of this tiny piece of rock compare to the mass of this large rock? Well, the large rock is heavier, people. This is not a trick question. The large rock is way heavier than the small rock. How does the density of the large rock compare to the density of the small rock? They're the same because they're made out of the same stuff, right? Smaller mass, smaller volume, same density. Greater mass, greater volume, same density. Okay, so density in general depends upon the substance, right? Whereas mass and volume depend upon the specific object. Okay, so we're defining density as mass divided by volume. Again, you've seen this before, I'm almost certain. So we can kind of go through this pretty quickly. Here is a chart, just kind of gives you some various densities. You don't need to memorize these, of course. You can look these up on the internet, or this chart's in your book. But you can see, we go all the way from here, 1.66 kilograms per meter squared here for helium gas. In this chart, all the way up to mercury. Now, mercury, notice there's no solids on here. Mercury is about the most dense fluid around. We're not going to say the most dense of all, but it is a very dense fluid. 13,600 kilograms in every meter cubed. To give you a ballpark, soil is something like 4,000 or 5,000 kilograms per meter cubed. So this is a very dense substance. Now, it's denser than lead even. Lead's somewhere around 11,000 kilograms per meter cubed, but neither of those is the densest object. Gold is ridiculously dense. If you had a piece of lead and a piece of gold that were the same size, the gold would weigh almost twice as much. So gold is very dense. The densest element is osmium, which has a density of over 20,000 kilograms per meter cubed. So here on Earth, you see a wide variety of densities. If we're talking about outer space, if we expand our search beyond the Earth, now we can get ridiculous densities. Neutron stars are amongst the most dense objects in the entire universe, and they can have densities greater than 1,000 kilograms, so that's more than a ton per centimeter cubed. So imagine having more than a ton of mass in an object that's, something like this big. Luckily, those aren't, stuff that dense isn't showing up on Earth. Definitely not in my basement. Okay.